Performing a hypothesis test for the mean or for numeric data. Okay, we're going to base this on the t-distribution simply because, again, here we can use a z if we know the standard population standard deviation, but that's pretty much never. Almost always we'll have to use the t-distribution. Okay, so this test statistic is based off of a t-distribution. Again, the signs in the alternative hypothesis will tell us about the type of test. Is it a two-tail? If so, then it's a not equal to sign. Is it a lower than test, lower-tailed, or is it upper-tailed? That you can find by looking at the alternative sign. How do the p-values work for t-tests? Here, let's imagine that our test statistic is 2.1 and the sample size is 30. Again, because we're using the t-distribution, we'll have to know the sample size. Okay, so here, if the alternative has mu is not equal to whatever the hypothesis is, fine, whatever. If it's not equal to, then it's two-tail. Okay, the test statistic is 2.1. We'll also look at the negative component. Okay, so negative 2.1 and positive 2.1. Again, because it's two-tailed, half of the p-value is in one tail, the other half is in the other. When you look at the degree of freedom, it is here the sample size minus 1, so that's 29. You'll go to your t-table. You'll go down and you'll find the degree of freedom is 29. Okay, so here's your t-table. That's what it looks like, the degree of freedom. You go to 29 and you're going to look in that row. What you're looking in that row for is for your test statistic. It was 2.1. I don't find it, but here, in between here and here, I find 2.1. So then I know that half of the p-value is in between 0.025 and 0.02. Okay, so here, half of the p-value, that's just this area, actually in this case it's just this area, half of the p-value is in between these 2 points. Okay, so I can't find it exactly, but I know what it's in between. Okay, if this is half the p-value, I can multiply this by 2, this by 2, and this by 2, and find that the p-value is in between 0.04 and 0.05. I know that it's not equal to 0.04, and I know that it's not equal to 0.05 because the t-value was not 2.15 or 2.045 like we found in the actual table. Okay, how do we calculate? So that's the best we can do for a table, is not give exact p-value, but say the p-value will be in between this and that. To find the exact p-value, you have to go to Minitab here. Okay, so let's go to Minitab, Calc, Probability Distribution. This is the t-distribution. Okay, I have the value, here's the degree of freedom is 29, and I have the value, it's 2.1. Okay, so here I'm going to use Minitab to find this cumulative area. So here's negative 2.1. Negative 2.1. Okay, so here, half of the p-value is 0.022271. If I multiply that by 2, then I get that the p-value in this case would be 0.044. As you can see, here you can actually find an estimate for what it is, and using the table, all we could say is that it is in between 4 and 5%, which is true. If the alternative hypothesis has the less than sign, then the p-value is everything less than the test statistic. The test statistic was 2.1. Here we go. Again, you'd get the degree of freedom. I'd look for this 2.1 value. Again, I see it in between these two. And here, again, it's in between 0.025 and 0.02. This is the tail probability. Okay, so another useful feature is you look up at the picture. It's telling you the right tail. This is the tail. This is the area that they're telling you about, is this area right here. Okay, so here I don't want this area. I want 1 minus that area. I want this area. So if I do 1 minus both of these things, 1 minus 0.025, 1 minus 0.02, I get 97.5% and 98%. So in this case, I know that my p-value is in between 97.5% and 98%. Again, drawing pictures really, really helps. If the hypothesis is an upper tail test, if the sign is greater than in the alternative, then the p-value is this upper tail, which we saw is exactly what our t-table is telling us. Here it is, the upper tail. Okay, so then we can just finally just trust what it tells us and say that the p-value will be in between 2 and 2.5%. Again, in Minitab we saw this. This was 0.022271. And here we'd have to do 1 minus this 0.02271, like that.